Hello everyone, welcome to another one of my Leetcode videos. In this one we'll do Leetcode 491, which is non-decreasing subsequences. So basically we're given an array nums and we need to return a list of all the subsequences with at least 2 elements where the subsequence must be non-decreasing. So basically it has to be either increasing or equal, right, to the previous element. And so in this example 4677, you can see that basically everything is an increasing subsequence. In this example, it's only 4, 4 because after that, everything is decreasing. So what will be our approach to solve this problem? So the idea or the intuition is basically to find, like, what if we had to find all possible subsequences, right? So how would we do it? So first, think about how to find all possible subsequences, right? And then from that, there are subsequences where we don't need to traverse because, if we find, like, for example, 4 and 3 is decreasing, we don't need to continue down this path because we already know that putting 4 and 3 together won't work. So basically then, after we have an algorithm to find all possible subsequences, we'll, filter out or cut down the paths where it's decreasing. And as we go, right, we'll add all of this to a result list and then return it, right? So first let's think about one. If we had to find all possible subsequences of the array, how would we do it, right? So let's say we have elements like 1, 2, 3, 4, 5, right? And basically at each element you have a choice, right, whether you should include it or not. So let's say we start with a empty array, right? Now in the first element is 1, so you can choose to include 1 or skip 1. So if we include it, we have this, and then if we skip it, we have this, right? And then for each branch we have the next element. So then in this branch you can choose to include 2 or not. So in this branch we'll have 1, 2, or just 1, right? And then in the other branch where we don't include 1, then for 2 again we have the same choice. We include 2 or not. So if we include 2, we'll just have 2. If we don't include 2, we'll again have an empty array, right? And so I'll just show you one more level. So the next, again, for each of these 4 children, the next choice is, should I include 3 or not? So in this one, if I include 3, that will be 1, 2, 3, right? And in this one, if I include 3, it's going to be 1, 3, right? And then in this one, there's another branch where I don't include 3, so it's just going to be 1, 2, right? And again, for this child, either I include 3 or I don't include 3, which will be just 1, right? And so again, we have the choice for this child whether we include 3 or not. So if we include 3, it becomes 2, 3. If we don't include 3, it becomes just 2. And then over here, again, we have the choice. If we include 3, it becomes just 3. And if we don't include 3, it becomes an empty array. So you can see the pattern. If we do this process until the end, until we processed all elements until 5, our leaf nodes over here will have all subsequences, right? Because as you notice here, you have an empty array. If you just take 1, 2, 3, you have an empty array. You have 1, you have 2, you have 1, 2, 1, 3, 2, 3, right? And then you have 1, 2, 3. So if you keep doing this algorithm where we at each node we make a choice whether to include or not, and then keep recursing, eventually when we hit the end of the array, the bottommost level of this tree will basically contain all of the possible combinations. And so once we get here, we can just say, okay, if the size of the subsequence is greater than 2, then we add it to our result, right? And then obviously if there are paths here, for example, if we see that, or let's say this was 2 and 1 for whatever reason, right? Then we know that, okay, this path is not worth exploring, so we can cut down a whole branch of the tree because it's already decreasing here, right? So that's how we can filter out our branches. So again, this will be kind of a recursive solution where we'll cut branches and reach the end of the array, and when we reach the end, we'll add it to our result. So let's see how that looks. Okay, so we'll start out with a set of list of integers. So here we can get results that are not duplicate, and this will be obviously passed to our recursive function. And then let's call our recursive function, let's say populate results, right? And then we'll pass nums and the current index, which is basically start at 0. We'll pass the result, and we'll pass a current subsequence value, which will just initialize to an empty list. So this will be the subsequence as, you know, it's recursing and going through the tree. This will keep track of the current subsequence. And at the end, we'll just return new array list. So since they want a list, we'll convert this set back into a list like this. So now let's write our recursive function. So I've gone ahead and written our recursive function. We have the nums array, the index where we're at, the result set, and the current sequence. So first, let's check if we've reached the end of the array, because this means we need to process our subsequence. So if index equals nums.length, that means we've reached the end of the array. And if the current sequence.size is greater than or equal to 2, because we need the size to be at least 2, then we add this sequence to our result, and we'll create a copy because we might keep mutating this as we recurse. So we need to create a copy of this sequence so it doesn't get mutated by other operations. And over here we'll just return, right? So this will be void because it will just populate result. So this is our base case. Now in our non-base case, we have two choices here for nums, right? So option 1 is add it to subsequence, right? And option 2 is skip it. And option 1, we only do it if nums at index is still non-decreasing, right? So again, we'll say if the previous element, so this is the previous element, so if that element is greater than or equal to nums at I, that means it's still non-decreasing, right? Only then we do this branch. But if you notice, this can overflow because initially our curse sequence will be empty. So we'll also check that. So if the sequence is already empty, right, or if the previous element is greater than or equal to our current element, only then do we explore this branch. So in this branch, what we'll do is we'll add our nums at I, or this should be index. So we'll add our nums at index to the sequence, and then we'll recurse to explore that branch. Everything the same except index plus 1, because we now added this one and now we want to proceed to the next element, right? And at the end, when we've done this, we'll remove what we added. So that's the last element index. So we'll remove that index from our sequence. And then option 2, this is regardless if it's increasing or not, right? Because we can always skip any number, even if it's increasing. So this one we'll just explore it regardless. So this is the other branch where we don't include this number. Yeah, so this should basically do it. Let's try to run it and see how this does. Okay, I messed this one up. This is supposed to be less than equal to, because that's how it's non-decreasing. All right, accepted. Let's submit. Perfect. Thank you so much for watching. I'll see you in the next video. Cheers.